With section 15.4, we're going to be multiplying and dividing radicals. And we'll call this part 1. So in general, the way this works is when multiplying radical expressions, we want to multiply the outside numbers separately from the radicands, which are the inside numbers. And then, of course, we simplify. Let me show you some examples here. What we're going to do first is multiply and simplify. The first one is the square root of 12 times the square root of 3. 12 times 3 is 36, and the square root of 36, of course, is 6. So what you do is you just multiply first and you see what you get. Square root of 3 times the square root of 6 is the square root of 18, which we've talked about simplifying these before. It's just square root of 9 times the square root of 2, or 3 root 2. Square root of 5m times the square root of 5m. We're multiplying the inside numbers, the radicands, and this is just the square root of 25m squared. Which, to simplify, we just do the square root of 25 and the square root of m squared, which is just 5. And we have a group of m, so just 5m. Right. It's similar to if we had 5 root 5 squared. The easiest way to do these is just to write it out. So this is just 5 root 5 times 5 root 5, or 25 times the square root of 25. We're multiplying the outsides and we're multiplying the insides. Square root of 25 is just 5. 25 times 5 is 125. All right, how about the square root of 4xy squared times the square root of 16xy. 16 times 4 is 64. X times x is x squared. Y squared times y is y to the third. So to finish this, square root of 64 is 8. The square root of x squared is just x times x, or just x. And the square root of y to the third, right, y 3 times. Here's a group with 1 left over. This would be the answer for this problem. Yeah. Because it follows. So the question was, how did I get y root y for the square root of y to the third? And it follows the same rules that numbers do. So just like if you had the square root of 8, 2 times 4, 2 and 2. But really, the square root of 8 is just 2 times 2 times 2. There's a group of 2s and a 2 left over. Why should it be any different if there's letters, right? All right, what else here? How about the square root of 10 times the square root of 3 plus the square root of 7? These aren't the most exciting problems in the world. A lot of it is just practice to expose you to different types of problems. So we're just going to distribute here. And we get the square root of 30 plus the square root of 7. Now, I don't think anything goes into the square root of 30. We could check. It's just 3 and 10. 10 is 2 and 5, so there's no groups there. Similarly with 70, it's 2 and 35, which is 5 and 7. There's no groups there either. Our final answer would just be that. Just like we could multiply one term by 2, we could also multiply 2 and 2. So like if we had 3 root 7 plus 1 times 2 root 7 minus 8. We could FOIL this. So what we're going to do is 3 root 7 times 2 root 7 plus 3 root 7 times negative 8. And then plus 1 times 2 root 7. And then plus 1 times negative 8. So it looks like regular binomials. And then simplifying this would just be 6 root 49 minus 24 root 7 plus 2 root 7 minus 8. Or just 6 times 7 minus 22 root 7 minus 8. 7 times 6 is 42. 42 minus 8 is 34 minus 22 root 7. We'll do one more of these. If we had the square root of 10y plus 7 to the second. Just like before, we're going to write this out twice. And then we just distribute. So it should be the square root of 100y squared plus 7 root 10y plus 7 root 10y plus 49. This would just be the square root of 100, which is 10. The square root of y squared is just y, like we saw, plus 7 root 10y. We can't simplify those, but we can combine them to be 14 times the square root of 10y plus 49. And then there's nothing further we can do. That's pretty much how we multiply radicals. And then we'll finish this section with talking about dividing. We'll just say divide and simplify. The way that we do this is we try to combine as a radical just with one fraction. And then we simplify. I'll show you what I mean. So like if we had the square root of 75 over the square root of 3. One rule with radicals is it says if you have the nth root of a fraction over the nth root of a fraction, you could just combine this to be one whole fraction. And similarly, you could separate it too. If you have one fraction, you could split it up into two separate ones. So what I'm trying to say is we could just make this the square root of 75 over 3, which is the square root of 25, or just simply 5. So it looks kind of complicated the way that it was, but if we just simplify, it's simple. Similarly, if we had the square root of 21 over the square root of 3, that's just the square root of 7, which can't be simplified anymore. Or the square root of 60 over the square root of 5 is just the square root of 12, which is square root of 4 times the square root of 3, or 2 root 3. right? Or square root of 48 c to the 7th divided by the square root of 3c. "48 divided by 3 is 16. And you guys remember what we do if we have the same bases? What do we do with the exponents? Yeah, c to the 7th divided by c to the 1st as well. We subtract them, so this is c to the 6th. This is just the square root of 16 times the square root of c to the 6th, or 4. But we have to write c 6 times and figure out how many groups of 2 there are. Here's a group, and here's 3 groups of c's. So that would be the answer. Do one more. How about the square root of 64 x to the 3rd y to the 5th divided by the square root of 2xy squared? "64 divided by 2 is the square root of 32. X to the 3rd divided by x to the 1st is the square root of x to the 2nd. And the square root of y to the 5th divided by the square root of y to the 2nd is the square root of y to the 3rd. Square root of 32 is just square root of 16 times square root of 2. X squared is just x times x. And y to the 3rd is just y times itself 3 times. So let's see what we get. This would just be 4 root 2 times a group of x's times a group of y's with 1 left over. The way we combine our final answer is we write everything on the outside, so 4xy, and then whatever's on the inside.